continuing with a series of videos on HPC and cuda, and this video, this is the 19th video, is going to be totally different from the past videos. Here, this is the first time we are going to do Python programming with cuda in HPC. Now, using cuda in Python, how to do that? To run Python programs and install Python packages, we need to set up a conda environment actually. So that is the first thing we have to do. To run cuda on Python, we need to install number library. And installing a library can only be done inside a conda environment, which can be easily set up. So how to do that? That is what we are going to see. So there are a few commands which you need to know. To set up the conda environment, you have to follow the steps like module load mini conda. This will load the conda module, and conda list to check all the variable environments. Then conda load, then whatever environment name you are given. And to create your own environment, you have to say conda inform -env to check the list of available environments. Now conda create minus name, then environment name. This will create a minus. This will create my-env. That's a new environment. Now conda activate my-env, that is to activate the environment which we created, and conda list -n the environment name, that is to check the list of modules installed inside that. For example, conda space list -n my-env will check all the list of modules. Now after this, you can install the desired modules using the command in the environment. So conda install package name. So for example, suppose I say conda install number, that is what actually we will need to do to import all the cuda libraries from number. Now in order to run the program, compiling and profiling, that is what actually we used to do, profiling in the C program. Now in this particular case, actually also you can do profiling. So once the environment is set up and the required library is installed, we can use a Python compiler to compile and run the program. So Python 3 and whatever Python file name is, that is the way you run the program. So after that you get the output, and also if you want to profile it, like to create report file, nsys space profile -o, the profiler name, profile file name, then the report file name, in fact output file name means that only, then the file to be executed. It will generate nsys report which can be opened and viewed using NVIDIA Insight systems, which we have been discussing from Windows GUI. Now the first program, which looks like that, here you can do the from numpy import cuda, then import numpy is for the arrays actually we use. So basically we are trying to add two numbers, 2 and 7, which is kept in an array. And unlike like earlier, actually the variable has to be ported to the device. So here the function is cuda.toDevice. It's much more simpler than pointer based C relocation. Now here it is. So again, now threads per block, we need only 1, blocks per grid only 1 you are taking. Then you can launch the launching the kernel. Now it is looking very different. The syntax, the addnum, that is the function name which is going to be running in the GPU. Then blocks per grid, comma threads per block. It is like two different arguments like earlier and whatever variables you are passing. And finally you get the C back and you are printing on the CPU. Now that was a simple program. Now if you want to do okay, in fact this is the same program, so in which you can see same thing here. This is from the editor, that's all. So it looks same thing, it is same. Now in order to compile this, Python 3 and file name, so you get the output, that's it. Now we have also done another example, that is example 2, where instead of just adding two numbers from single elements, now we have 1000 elements, and try to see, and also we'll try to compare and also profile and see how much difference it makes when we do Python. And as such, we know Python is slower compared to C++ or C. So we will do the comparison. So here n is equal to 1000 means 1000 elements, and just initialize with zeros. Then exactly like earlier, DA, DB, D underscore A, D underscore B, D underscore C are copied to device A and B and C. Then you define a block size, 256 threads per block, and we have the earlier formula n plus m minus 1. So here m is replaced by the block size. So there is a number of threads per block, and you start a timer inside. In order, why we need to start a timer? Because there are two timing. One is a time taken by the GPU, the other time taken by the CPU for other overheads. So we are interested only time taken by the GPU. That's why we start a timer well inside before starting the kernel. So then we launch the kernel here. Vector. So now do everything, and Hulda synchronize is anyway required. So after that you end the timer here. So after timer, so this time will contain the time taken by the program to run. So you see the results are coming correct when we execute this using Python 3, the file name, and time taken is also 158 milliseconds. Now we are going to see a demonstration of this in the real setup. So in order to do that, actually what we do is we are going to go to the AnyDesk and connect it to the HPC system. It was like we are connecting to that. So we are remotely connecting to the HPC. So now we are connected. Now you can see we are well inside the HPC. Now srun minus instead of doing all the srun commands etc., it's all put in a start script. So you can see the what is inside the start script is just see if you. So this is what my srun minus n, one node, and 2 GPUs node actually it is. That's all, and you are seeing which GPU is allocated to you, which node is allocated, not GPU, which node is allocated to you. So this is script which we ran. Now next we are going to module load like earlier. Now instead of the cuda thing which we used to do earlier, now we are doing mini cuda. So after doing this, now the mini cuda is loaded. Now again we are coming back to the commands which we were discussing. It's like conda info minus env. So if you go back and see the slides, actually you see the commands were here. That is what we are trying to do now. So when we said conda info minus env, it showed all the environments actually. existing. Conda activate my NV is here. Okay, this is how we execute the program. Python 3 this thing. So this the conda activate my environment is a environment which was created earlier. So this is the environment. So now we are executing the program. Now the program is running. So if you look at the commands, actually the in order to create the environment, actually we had the command conda create environment. So this was created earlier, my env. So all this was used and it was activated also. That is why we were able to reuse that and executed. The program got executed. Answer came 9 is fine. 1 warning is fine. Now next thing what we are going to do is we are going to next program we are running where 1000 elements are there. See, it added one by one and it gave the result, giving the result, and it is matching. So we are not interested in how much time it is taking to print. Print of is not important to us. We want to see how much time GPU took is 185 milliseconds. So compared to earlier, the earlier this is taken 185 millisecond. The earlier one had taken 2.3 microseconds. So the earlier case, that is one variable addition. So
I was comparing with the C++ program.
in the C++ it was taking microseconds exactly, and here it's taking in millisecond, lots of millisecond. So because it's a slow thing, but the program which was to add 2 plus 5 is equal to 7 in one single element, it was taking almost similar time. Okay. Now, so this is what is the demonstration of this, and so see you in the next video. Thank you.